All right, so I want to use synthetic division to check and see if something is a factor. So there's kind of a link between factors and zeros that I will save for another video. But essentially, what a factor is can I divide this polynomial by this factor and get out another polynomial, right? Well, how do we check that? If we get out a polynomial that doesn't have a remainder, then we know that it works, right? And that seems maybe a little bit strange, but if we do have a remainder, you'll remember that we have kind of a strange term on the end where we have something divided by what we were dividing by. So in this case, something divided by x plus 5, and that's not a polynomial term, so that would mean that our resultant, what we divided out, would not be a polynomial, and so that would mean that x plus 5 is not a factor. On the other hand, if we divide by x plus 5 and we get no remainder, then x plus 5 is a factor, and so the method that we're going to go about checking that is just going to use synthetic division because it's quick, it's relatively straightforward, and so this will also function as a little bit of a synthetic division review as well. So first things first, I want to go about checking that my polynomial that I'm dividing is in standard form and that there are no missing terms. So I've got x to the 5th, 4th, 3rd, 2nd, 1st, 0th, all in order, nothing missing, so we're good to go. So I'm going to start pulling off coefficients. So the coefficient of x to the 5th is just 1. 7x to the 4th, the coefficient is 7. 16, 39, 46, and 5. So I've got 6 terms, 6 coefficients. I'm going to write all of those coefficients in order without the x's, so I'm dropping the x's. So I've got 1, 7, 16, 39, 46, and 5. Next thing I do is I take those and I put it in this little bracket thing here. Okay. Now, if you'll recall, we want to take what we're dividing by, so in this case, x plus 5. We're allowed to use synthetic division because x plus 5 is a linear term, meaning it's just x, as well as there's no coefficients out front of x, it's just a 1, so we can do synthetic division. I want to take whatever the value is, so I had x plus 5, I want to take that 5, and then I want to switch the sign and bring it down to the outside here. So it was positive 5, so I want to switch it to negative 5. All right. Now I'm set up and I'm ready to go. So step 1, I bring down the 1, and then I do 1 times negative 5, which will leave me with negative 5. And I put that in the next column over, and then I add down. So 7 plus negative 5 is 2. Right. Next, I take 2 times negative 5, which is negative 10. Put that in the next column over, and now I add down. 16 plus negative 10 is 6. Okay, 6 times negative 5 is negative 30. Put that in the next column over, and I add down. 39 minus 30 is just 9. Next column, negative 5 times 9 is negative 45. And, oh, sorry, that's my bad. Negative 45, and 46 minus 45 is going to leave us with 1. And negative 5 times 1 is going to be negative 5, so we put that in the next column over. And 5 plus negative 5 is going to leave us with 0. Right? So things to watch out for are making sure that you remember your negatives and just making sure that you line everything up. Now I want to check and do 2 things, check and see if this is a factor, and also maybe put the x's back in, although that wouldn't answer our main question. And to check if this is a factor, we look at our remainder, which hopefully you'll recall is our last term. Once we've divided. And so because our remainder is 0, we don't have a remainder, so it turns out that x plus 5 is a factor. If that was instead a 1 or a negative 20 or any positive or negative number other than 0, then it would not be a factor. But the fact that it is a 0 means that x plus 5 is a factor. And if we wanted to, we could work back from there, adding in our x's. So we've got x to the 0, x to the first, to the second, to the third, and x to the fourth. Right? But the key here is that x plus 5 is a factor. If you have more questions, feel free to send me an email if you'd like more problems, that sort of thing. But that is how you check if a linear term is a factor of a polynomial using synthetic division.